Second part of chapter 2, we're getting into the structure and function of joints. So we're going to talk about the different classifications of joints on a couple different levels. In your lab manual, there is on page 19, there is a little joint classification worksheet sort of that we will go over in lab. So if you want to take a look at that and, start filling in those boxes, you could do that. Any of the material in the lab manual, you're going to get so much more out of lab if you know what you're getting into. So open up that lab manual and take a look at what's going on there. And if you go into lab knowing what to expect, you're going to get more out of it. The nice thing about lab is that we can palpate things, and we can touch things on people, and we can look at bony models and touch bony models. So you're going to get a lot of hands-on in lab. Yay, right? So the learning objectives for this section are to list and describe the three primary classifications of joints and provide examples of each, and identify the 7 types of synovial joints and give an example of each of those. And so easy, right? We can do that. So the 3 main classifications of joints are synarthrosis, amphiarthrosis, and diarthrosis. So, and diarthrosis is the synovial joints. So synarthroses are junctions between bones that allow little to no movement, and their primary function is to firmly bind the bones together and transmit forces from one bone to another. So in the sutures in the skull are a good example. They're not supposed to move. They're supposed to, keep your brain on the inside where it's supposed to be. It works better that way. But there's probably, it's not that there's no movement, there's little to no movement. And of course, in babies, before the sutures have fully cemented, there is less movement. So amphiarthroses are usually formed primarily by fibrocartilage and hyaline cartilage. They allow limited amounts of motion, but they do allow motion, and their primary function is to provide shock absorption. So an excellent example of the amphiarthrotic joints are the intervertebral discs. The intervertebral discs and the 2 vertebrae that surround them. So the spine needs to disperse large compressive forces, and it's going to do that through this cushioning effect of fibrocartilage and hyaline cartilage combined. So we're going to talk in detail about the spine later on, but the amphiarthrosis is a super important joint in our body. Diarthrosis is the synovial joint, and a lot of what we talk about in this course is going to have to do with individual joints and the muscles that work them. So the articulation of a diarthrosis is a fluid-filled joint cavity that's between 2 or more bones. So when we're at the knee and we have the articulation between the femur and the tibia, you could also call it the tibiofemoral joint instead of the knee if you want to. It is surrounded by that synovial capsule filled with fluid, and there are 7 uniquely functioning categories of synovial joints. So the knee joint, the tibiofemoral joint, is a condyloid joint. And we'll talk about the other classifications. So all synovial joints share some common attributes, and here they are. So one of the most common, one of the things to remember about synovial joints versus amphiarthroses or synarthroses is a synovial joint includes synovial fluid, which provides joint lubrication and nutrition. So some of the changes in osteoarthritis have to do with wear and tear on the bones, but some of them have to do with chemical changes in the synovial fluid. So the composition and thickness and function of the synovial fluid is really important to how our joints work. When your synovial fluid starts to break down, you start to see little pits and things in your hyaline cartilage at the end of the bones, and that's no good. So it just doesn't glide the way it's supposed to. The articular cartilage in the joint dissipates and absorbs compressive forces. That's our hyaline cartilage. So if you have little holes in something that dissipates and absorbs your compressive forces, you're getting more compressive forces, right? The articular capsule is connective tissue that surrounds and binds the joint together. So this picture is a cadaver picture of the articular capsule of the elbow, and you can see it's beefy. We've got collagen-filled tissues all the way around the elbow. And if you've ever done a cadaver anatomy class, there's quite a lot of dissection you have to do to get actually down to the bone, remove all that connective tissue. So our synovial joints our synovial capsules are quite elaborate structures. The connective tissue also gives us places for attachment, which is really nice. When people get a total knee replacement, they actually preserve the synovial capsule. So they put in the prosthetic at the end of the femur and the top of the tibia, but they preserve the synovial capsule. And a lot of our proprioception comes from messages coming from free nerve endings in the synovial capsule. And so that's why we can still balance after we get a total knee replacement. So the synovial capsule plays a big role in our lives, in all our joints. So that was 3 common elements of synovial joints. These are the other 4. The synovial membrane, which lines the capsule, it produces synovial fluid. So that's where the fluid comes from. Capsular ligaments are thickened regions of connective tissue that limit excessive joint motion. So we're going to talk about connective tissue in more detail, but you can think about ligaments as being like the strapping tape of the body. Their ligaments prevent movement, or they stabilize joint movements. Tendons transmit motions from muscles. So we need those capsular ligaments that limit our excessive joint motion. And when we talk about all the individual joints, we'll talk about the important ligaments in those joints. Our synovial joints also have blood vessels that provide nutrients to the joint. So that's important for maintaining these important structures in our body. We need blood vessels to get nutrients in and take waste products out. We also have sensory nerves in our synovial joints that transmit signals regarding pain and proprioception. So remember how I said in a total joint replacement, they preserve the synovial capsule? That's because we still want those proprioceptive signals. And pain, you know, we'll talk a lot about pain in the next year or so. So our 7 classifications of synovial joints, the simplest one is a hinge joint. A hinge joint allows motion in one plane about a single axis of rotation, similar to the hinge of a door. So the humero-ulnar joint, aka the elbow, is a great example of a hinge joint. Another really good example of a hinge joint is our interphalangeal joints in our fingers. They just move in one plane around one axis. Okay. A pivot joint allows rotation about a single longitudinal axis of rotation, like the rotation of a doorknob. So the proximal radio-ulnar joint is an example of that for forearm supination and pronation. A really good example is the C1, C2. That's a big pivot joint for pivoting our head. So the C1, C2 pivot joint provides a very large portion of the side-to-side movement in our heads, our rotation. An ellipsoid joint is a convex, elongated surface mated with a concave surface. So it allows motions to occur in 2 planes. The wrist joint, or the radiocarpal joint, is a very good example of this. So the carpals form that concave surface all together, and the end of the radius is the carpals form the convex surface, and the end of the radius is a concave surface. So we get motion in the frontal plane and motion in the sagittal plane, 2 degrees of freedom, and we get circumduction, because once you have 2 degrees of freedom, I'll throw in circumduction for free. You don't have to pay any extra for that. Ball and socket joint, it's your classic hip or shoulder joint. So it's an articulation between a spherical convex surface and a cup-like socket. It allows wide ranges of motion in all three planes of movement: rotation, abduction, flexion, extension, sagittal plane, frontal plane, transverse plane. 3 degrees of freedom, the hip joint, shoulder joint. Those are our 2 ball and sockets. And look at what we expect from our shoulders, a lot. Planar joint, or a plane joint, is the articulation between 2 relatively flat bony surfaces. It allows limited amounts of motions, and it might slide and rotate in different directions. So the intercarpal joints of the hand, so remember we said our carpal bones are like the little cubes, sort of. So their little planar surfaces can slide on each other in different directions and give us this motion in our hand, because they can move in a lot of those different directions. So planar joints have at least 2 degrees of freedom, at least. So maybe we'll say 2+. A saddle joint is a kind of a special joint. We have 2 places in our body where we have saddle joint. One of them is our right in our thumb. That's the thing that's why we rule the world. Well, one of the reasons. We can grab onto things. So it's why dogs and cats live with us, because we can open things for them and get them food. But our first carpometacarpal joint, the carpometacarpal joint of the thumb, is a good example of a saddle joint, and we'll look at it in detail when we get to that. Joint. The other saddle joint is our sternoclavicular joint. So we have 2 carpometacarpal joints, first carpometacarpal joints, and 2 sternoclavicular joints. Those are the 4 saddle joints in our body. So what the sternoclavicular joint is actually the only bony attachment that the upper extremity has to the axial skeleton. And so even though it doesn't have a huge amount of motion, it can move in a lot of different directions. And it's very important to the movement of the whole shoulder girdle. So we'll talk about that more when we talk about the shoulder. So that saddle joint, it has convex and concave in the same surface, in both surfaces. So you get a wide range of motions. So I'd say 2+ on that too for the number of degrees of freedom. So at least 2, if not a smidge more. A condyloid joint, that's our tibiofemoral joint, our major knee joint. The other joint in the knee is the patellofemoral joint, and we'll talk about its importance in the knee chapter. But condyloid joints are usually an articulation between a large rounded convex member, which is the femur in this case, and a relatively shallow concave member. So usually it's 2 degrees of freedom. So the knee is not just a simple hinge joint. It has a little bit of rotation too, and it has some functional significance. And we'll talk more about that in the knee chapter. But so we have 2 degrees of freedom in a condyloid joint. And some of our metacarpal phalangeal joints are also condyloid joints. So we have ab and adduction and flexion and extension to give us more mobility in our hand. So 2 degrees of freedom, not just a simple hinge, we've got more going on there.